Hi everyone, I hope you're having a great week so far. In this video, we're going to go through chapters 10 and 11 from your textbook. Firstly, we'll take a look at chapter 10, which is about developing whole number place value concepts. Now, before we do that, I thought it would be beneficial to briefly talk about the main takeaways from chapters 8 and 9 for two reasons. Firstly, because you had to watch those video lessons, and so this is just to make sure that you got the right information out of it. But secondly, we understand that math builds off of itself in a very structural and a very foundational way. And so the topics that you talked about in chapter 8, which were developing meanings for the operations and then developing fact fluency, those are all really important to what we're going to talk about today, which is place value and then developing strategies for addition and subtraction. So chapter 8 was all about developing meanings for the operations. And some of the key points there was that operation problems have different structures, right? You might have a change problem or a part-whole problem or a comparison problem or an equal groups problem or an array or area problem or a combination problem. So we kind of group them into those main categories. However, when we go to teach those different operations, it's important that we make them meaningful for students. So using story and context problems, maybe putting your students' names in the problems, or using a relevant class experience like a recent field trip that the students went on. And then also, it's important to begin introducing the properties of the different operations. For example, like the commutative property, where the order of addition of the numbers doesn't matter, or the associative property. And it's important that we just help our students start to understand how the numbers work in that way, but not to get fixated on the name of the property itself. So for example, we can still help our students learn that when I add two numbers, for example, 2 plus 3 is equal to 3 plus 2, we can start to help them understand that idea without bogging them down with the name commutative property. And then in chapter 9, you talked about developing fact fluency. Which is where we start at counting and then we develop reasoning and hopefully we end up at mastery. All basic facts should be taught with the intention of understanding rather than memorizing. So again, similarities from chapter 8, we want to use story problems and encourage our students to use strategies like doubling numbers or using 5 and 10 as anchors or using those one more or two more strategies. And then it was also noted that drill strategies, probably strategies that we encountered when we were students, like timed tests, things like that. The use of flashcards, that they still have value, but they should be used carefully. And those shouldn't be the primary method of teaching, but rather they should be used for practice and to help our students go from reasoning to mastery. And there's also an opportunity to incorporate technology and games to help with those things. So now we're going to jump into chapter 10, which is about developing place value concepts. And I just wanted to give you a chance just to maybe recall how you learned place value when you were younger. I have a very vivid memory of the place value chart on the left here, where my teacher would draw the straws and we would kind of move them over in bundles of tens. And then once we had a bundle of 10 tens, we would change that into 100. You might also have some memories of the base 10 blocks, which are on the right. There are those three-dimensional cubes, which then turn into a rod and then a sheet, if you will, and then a full cube. So these are all things that we'll talk about today as we look at how to help our students develop place value concepts. So we talked a lot about number sense last time before your test, and number sense is really important because it does link to our students' understanding of place value. And that also includes extending to decimals as it develops across the elementary and the middle grades. We've talked about before that by the end of first grade, students will have had exposure to digits up to 120. And then by the end of second grade, groups of 10 are formally connected to 3-digit numbers. And then if we jump all the way up to grade 4, students extend their understanding to numbers up to 1 million in a variety of ways. Then in 5th grade, whole number ideas are extended to decimals. And so place value, it's really important just because it serves as a gateway to all these other skills and ideas the students are taught in higher grade levels. It's a way for students to think about larger quantities and to enhance their ability to invent their own computation strategies. And so it's important then, because a lot of you will be working with younger students, right? Just to mention where students are at before they have this understanding of place value. So we're talking about pre-place value concepts here. And initially, when students are in kindergarten, their understanding of counting is strictly in a count by ones frame of reference. We'll refer to that as Unitarian, right? Just counting every single piece individually. And in other words, they never group things into 10, right? They just rely on single counting to get them by and to help them understand quantities. And so what you see on this slide here kind of serves as an assessment to see where our students are at with their pre-place value concepts. So you could ask a first or second grader to count out 53 tiles, and then just watch closely to note whether they count out the tiles one at a time, push them into a pile without any type of grouping, or group them into tens. And then you can have the students write the number that tells how many tiles they just counted. Now, again, that counting by ones, you will likely find that early on students count the tiles by one and are therefore in a pre-place value stage. So that's our main indicator. If a student is using that Unitarian approach, counting by ones, then they are in a pre-place value stage. So place value requires an understanding of an integration of new and sometimes difficult to construct concepts by grouping of tens with procedural knowledge of how groups are recorded in our place value system and how numbers are written and spoken. And so it's important that you are in tune with where your students are in their place value development. And so here on the slide, we are going to discuss three different levels, three different stages of understanding when it comes to understanding place value. So if we start at the top, all right, the first stage is the unitary stage. We were mentioning that briefly on the previous slide. So that's where a student counts by ones. And so in this scenario, the example scenario is what we had before, where you're asking a student to count to 53. And so, of course, in the unitary stage, they're simply just counting every single piece individually, one by one. And so in this stage, a student can name a quantity or tell how many just by counting each piece. They are not yet able to think of 10 as a single unit, and they use counting by ones as the only way they are convinced that different sets have the same amount. Then we go on to our middle stage, which is the base 10 stage. In this stage, students count a group of 10 objects as a single item, and so they are starting to understand that 10 is a unit in and of itself. They coordinate the base 10 approach with a count by ones to as a means of telling how many. And so again, they might group initially, but then they might have to recount using the Unitarian approach to make sure they have 10. And they use the second version of the count and explicitly state the number of items. So again, starting to have that understanding of grouping, but it's still pretty stagnant. And then we go on to our last stage, which is the equivalent stage and the non-standard base 10. So in this stage, students are able to group the pieces flexibly into versions that include tens and ones, but all trades have not been carried out. In this stage, they use alternate groupings to relate to computation by being able to trade or regroup numbers in a variety of ways. So I think the key here and just the main difference between that second stage and this last stage is just the idea of being able to group the items flexibly. And if you kind of consider that subitizing idea we talked about before as well, right? Just being able to look at a group and understanding there are 10 items there. And so that's where we want our students to end up. And so again, the idea of us as teachers asking the right questions to help our students understand the different stages and travel through them. One example of a good question you could ask to help encourage students to advance through the stages could be something like, what would happen if we count to 53 by tens and ones? So thinking about those stages of questioning from before. Now, there is this thing called the integrated place value model. And as you can see, it looks different than the place value model that you probably worked with when you were in elementary school. And it's integrated in the sense that it helps our students make the connection between the visual representation of the number and the way that we would write it, right? So we talked about this before as well, that it's really important that our students not only know how to count and start developing these concepts, but that they know how to express themselves and they know how to write the numbers and how to kind of translate from the model to the number specifically. So this place value model, I think, is a good way to help your students bridge that gap. So they start with their groupings of 10, and those are matched with specific numerals. So I have 5 10s and 3 1s. And then we explicitly write those numbers out, and then we put them together to come up with the number written in standard form. So this is just a good way to help our students kind of build that literacy. So there are many physical models for base 10 concepts, and they actually play a really important role in helping our students develop the idea of a 10 as both a single entity and a set of 10 units. An effective base 10 model for ones, tens, and hundreds is one that is proportional. And that idea of this proportionality is super important. So this means that the 10 is physically 10 times larger than the model for 1, and 100 is a 10 times larger than the 10 model. So there are two main groups of base 10 models. They can be either groupable or pre-grouped. The groupable base 10 models are what you see on the left-hand side of the screen. And these are all made up of single pieces. So you might be familiar with these cubes here, the stacking cubes that link together. And so those are all individual pieces, but then when you stack them up, it becomes one unit of tens. There are also other materials you can use if you don't have specific math manipulatives. For example, like you can get beans or counters or pennies and use those as groupable base 10 models. And then the bundles of sticks or straws or coffee stirs is also very popular. Then our second group is called the pre-grouped base 10 models, and these are just like they sound, they're models that already have these groupings set. So, for example, like strips and squares and single pieces, which are kind of like the two-dimensional version of base 10 blocks. We also have then our three-dimensional version of base 10 blocks, and then we talked about these during our other class, the little 10 frame cards, right? So those are all what we would call pre-grouped base 10 models. Now, again, all of these are really important and we can use them in many different activities. Now, it's important to note, though, that when you move from the groupable base 10 models to the pre-grouped ones, that you make an extra effort to confirm that your students understand that a 10 piece really is the same as 10 ones. And then for the pre-grouped cube, make sure you show the students that it is in fact 10 hundreds. So it's a good idea to verify that those units do translate before you have students use them in different activities. And bottom line is that it's imperative that students have sufficient experience with groupable models before moving on to the pre-grouped ones. Now we're going to take a look at some activities that help our students develop base 10 concepts. As we look through these, though, it's important to note that in all of these activities, the oral and written names for the numbers can and should be developed together with the conceptual idea of base 10. Because students start or approach base 10 with a count by one's idea of a number, it's important that you begin there, meeting your students where they're at. Students do need to experiment, though, with showing amounts in groups of like size and perhaps come to an agreement that 10 is a very useful size to use. So we're going to start by looking at activity 10.2, which is the activity on the left side of the slide. This is on page 218 of your book. This activity is called Get This Many. In this activity, the students count the dots that are here on the bottom of this piece of paper or this worksheet. And then once they're done counting the dots, then they count out a corresponding number of counters. So here they're just using toothpicks, beans, and washers. And you can notice here on the right side of the worksheet that the student is also encouraged to write down the amounts of tens and the amounts of singles that they have. And then here they're writing out the actual number word, spelling it out. Okay. Now on the right hand of the slide, we have two additional activities. And these ones, the student is first given a verbal name of a number. So as the teacher, you would kind of say that verbal number out loud. And then the students must count the indicated amount and make groups. So for example, here on the first one, it says get 47 beans. So students are asked to count out that number of beans, and then they would illustrate that using the 10 frames. to notice that, okay, well, 47 beans, I would have 4 sets of 10 and 7 singles. This one underneath is very similar. It's called loop this many. And so here students are asked to loop 62 in groups of 10. And so they would just circle the groupings. And this activity in particular is one that helps them transition to that very final stage of base 10 understanding, because it allows them to group the numbers flexibly. Because as you can see, there are only 4 rows here. So it's they won't have an even number of columns, I should say, that fit into a group of 10, as compared to the activity above, though, that uses the 10 frames, right? We all know that every frame does include 10. And so here in the loop this many, it helps them with that flexible grouping. Another really fun activity are these base 10 riddles. This is activity 10.7 on page 222. And here you could create riddle cards where you write the riddles, or you could just have them as slides on a PowerPoint and show them to your students. You can read the riddles out loud or present them orally, or present them in a written manner. But here it's just like what it sounds, right? A student, you once presented with the riddle, is trying to figure out what number you're talking about. So like the first one says, I have 23 ones and 4 tens. Who am I? So again, just a really great way for students to work on these place value concepts in a fun way. And this activity in particular, it incorporates the oral language with these equivalent representations, which is really important. On the slide here, you see 2 different place value mats. The one on the top with the beans just has tens and ones, and then the one underneath it with the base 10 blocks has hundreds, tens, and ones. And these, they're simple mats, right? And they're divided into these different sections, but they do help reinforce the concept of groups of 10. And so the use of these place value mats, it does provide a method for children to organize their materials. And then using the 210 frame method in the ones place and the bottom there does help to eliminate the repeated counting of ones, because you're using that second 10 frame. Now, in your textbook, there are these things called place value cards, and it's another valuable tool. You can find those on page 226 of your book. Now, also, when it comes to internal zeros in the tens place, for example, like with a number 702, that can be challenging for some students. So just address the misconception beforehand and say, with a number like 702, you could have your students say that there are 700s, 0 tens, and 2 ones, just to get accustomed to that connection there. And now we also note that in both of these mats, they have a left to right design, meaning the biggest unit's on the left and then all the way on the right is the smallest unit. This is important too, just because it helps our students connect the oral names to the written numbers, right? Because that's how we write out our numbers. The biggest number or the biggest place value is always on the left, and the ones are always on the right. Now, here's an assessment tool for you. And so there are 5 distinct levels of understanding of place value. And you, as the educator, should be in tune to each of them so you can help your students progress through each. So the first stage is single numeral. And in that stage, the student writes 36 but views it as a single number. The individual digits 3 and 6 have no meaning by themselves. In the second stage, which is called position names, the student correctly identifies the tens and the ones positions, but still makes no connections between the individual digits and the blocks. Then in stage 3, we're at face value. The student matches 6 blocks with the 6 and 3 blocks with the 3. And then in stage 4, we transition to place value. So the 6 is matched with 6 blocks and the 3 with the remaining 30 blocks, but not as 3 groups of 10. And then full understanding is that the 3 is correlated with 3 groups of 10 blocks and the 6 with 6 single blocks. Now, if you were to put a student through this assessment, you could pick a number like 36, which was the one that was put into the different stages here below. And you could ask them to write out that digit, or you could write the digit for them. And then you could ask them to circle a 6 on the board, and you could ask, does this part of your 36 have anything to do with how many blocks there are? And then you could circle the 3 and ask the same question. Does this 3 have does this number or does this part of your 36 have anything to do with how many blocks there are? And so just in the way that they respond, you'd be able to place them in one of these 5 stages. All right, so now we're going to talk about some patterns in our number system and how numbers are related, right? We know that math is the study of patterns, and so patterns come up a lot, and they're important to our students' number sense and helping them build these concepts. And so we're in particular interested in the relationships of numbers to important special benchmark numbers and 10 structured thinking, because these ideas begin to provide a basis for computation. And if you've ever seen a hundreds chart, right, this is a really important tool in the development of place value. And in this numbers chart, it's also a really great place for your students to see the different patterns that form, and through place value, what those patterns are. So for example, you might notice that if you just pick the first column, or anytime you go down a row, right, it's 10 greater than the same box in the previous row. And so there are lots of different patterns that students can notice. It's important that they know or see the relationships with landmark numbers like 10 and 5. And this does help lead them to different number relationships that help with addition and subtraction. So here's an activity that helps your students with these patterns and just understanding how they would help them with understanding of place value. It's called Finding Neighbors on the Hundreds chart. So you could give your students either a completely blank or nearly blank hundreds chart, just like I have here on the slide. And you can circle a particular missing number, such as that one there. And then you can have students fill in the designated number in the circle and find all of its neighbors, so all of the surrounding digits, just based on referencing the numbers that they have there. And so that just ensures that they see the patterns, they know the patterns, and they're able to apply the patterns and their place value understanding to find that missing number. Let's talk a little bit more here about benchmark numbers. So one really valuable feature about the hundreds chart is how clearly it illustrates the distance to the next multiple of 10, which would be the end of the row on the chart. Multiples of 10, 100, and other special numbers like 25 are called benchmark numbers. And students understand and gravitate to referring to such numbers this way when describing their problem-solving approaches. So let's take a look now at the activity 1017 on the slide, which gives students special practice and spatial practice with the benchmarks. And so this activity is called Who Am I? And you would need a long line or a strip of paper labeled 0 and label 0 and 100. And in this activity, you would mark a point with a question mark that corresponds to your secret number. Then you would have students try to guess and label and mark that number on your line until your secret number is discovered. And there are some different variations. You can change the endpoints. You can have from 0 to 1,000, or you can go from 200 to 300, or 500 to 800, etc. So it's important that we're also helping our students extend their understanding of place value from 100 all the way through and beyond 1,000. And so you should first, in order to help your students do that, you should first generalize the multiplicative structure of the number system, and that's shown visually on the slide. So what we mean by that is that 10 in any one position makes a single thing or a single group in the next position. So 10 ones makes a 10, 10 tens makes 100, 10 tens makes 10 hundreds makes 1,000, etc. Secondly, naming numbers requires stating the place value of every third digit. So like if I said the number here on the bottom, 4,028,360,400, right? I'm saying the place value of every third digit, right? 4,028,360,000, etc. And so this does connect visually to the shapes in the top right of the graphic and forms a pattern as seen at the bottom. It is important for students to realize that the number system does have a logical structure to it. And we refer to that again as kind of like that triple system for naming large numbers.